Okay. Okay, I'm Professor Jelena Vasiljević from Belgrade, Serbia. I will present you my research work, application of computer intelligence system in tumor diagnosis, and we have special projects with finding predictions actually of efficiency of application of chemotherapy in cancer diagnosis. I will present you later about that. So, first of all, for my PhD, now 11 years ago, I applied the multifractal analysis actually before neural networks, CNN, in cancer diagnostics and prediction of efficiency of chemotherapy. I have done that research with the medical faculty in Belgrade, with the Institute of Oncology, with Professor Jelena Vasiljević, and Institute of Oncology after Dr. Marko Radulović, University of Belgrade, medical faculty, and it was my actually PhD, and before that it was my, in that time, magisterium, something like master, but higher. I used to work in Institute Mihailo Pupin. Now I am teaching on the University of Union. I am representing here my faculty School of Computing. I teach neural networks, artificial intelligence, genetic algorithms. Used to be specific subjects like fuzzy logic, knowledge-based systems, robotics, and I have my subjects on PhD studies, multifactorial medical image analysis. But we nowadays for research we are combining and multifactorial and fractal and neural networks, specific CNN, if you know convolution filters. Yeah, it's really good for applying on medical images or any images, because you get on that way more images, more data, bigger data sets. Nowadays, you don't have to wait for big data sets like I used to do for my PhD. Nowadays, with the CNN, you can just multiplicate those images. So first of all, why fractals and multifractals? And multifractal analysis of image, if you can see, if you know the background of this image. Do you know what is it? This nice picture. You can suppose, yeah, it's, have you seen it before? Maybe on your desktop, like screensaver. Yes, it is fractal. And the main characteristics is that each part of that picture in itself contains the whole picture, like self-similarity. And the first application was in explaining of theory of chaos. It's not really so chaotic, and that's why idea to apply on explaining of cancerogenosis. Actually, and cancer cells are not so chaotic, divided. They have some explanation with multifractal and fractal equations. That's why in my idea and before me, researchers apply that on medical images in explaining how it grows. So some advantages of specific fractal and multifractal analysis, image analysis, are furlough of filtering, furlough of degradation of original image, and that way of regularness analyzing. There are many nowadays papers of explaining why fractals and how then they can describe those pathological structure of tumors. And fractals attribute explanation mechanism of tumor growing, as I said, of that chaotic and first of all, that self-similarity characteristics. So for actually, this was my PhD. We had 3 data sets with actually it was kind of interesting that they have biopsies from bone, actually leg bone, and they are searching. It was metastatic, bone metastatic, and they are searching for primary carcinoma. When they have metastatic, they search for where it started. On that way they can apply therapy on on the cause of that disease. Before that, I didn't know that there is some hope after metastatic. Actually, my father died when I was little from metastatic. That's why I am, in that kind of research all my life. So we had the 3 data sets: primary with primary lung carcinoma, primary breast carcinoma, and primary renal cells carcinoma. Actually, in my research, I always ask medical doctors where they have some, kind of problems. There is no, why should we do something that where they are sure, So they told me, my co-mentor from medical faculty, pathologist Jelena Vasiljević, she told me that she has problem with finding lung, breast, and renal cells carcinoma in biopsies of bone metastatic. So we applied FRACLAC from Australia program it is like a plugin in ImageJ. If you have heard of that program, it's really good. And before this, I had project with professor from Australia, Audrey Carprian, and she applied that program on big data, big image base. For magisterium, actually, I applied and FRACLAC, that program, and from INGRIA in Paris, if you have heard, there is institute in Paris applying fractals on medical images. But my comparison, my results were that this from Australia is much, much better. It can be applied on big data, as I said. So I applied FRACLAC, and after that statistical data analysis, data registration, which I think much better than SPSS, which is commonly used in medical and psychologist analysis. In data registration, you have 3 and much more statistical analysis, which I find much more precise. So these are 6 parameters from fractals that I have analyzed. And general hypothesis was that those parameters, fractal parameters, will be in correlation with those primary cancers. I had 1,050 tissue images, which is really, really high number. It is the hardest part of research to find big data sets. But as I said, nowadays, I saw even science papers with only 50, images applying CNN. So that is big benefit of neural networks, specific CNN. So I had 1,050 in three groups. So it's interesting. As I said, they took from bone, from leg, I think, from bone metastatic, and they are searching for totally different, types of, organs. it's really, it was really fantastic for me to, it's really hard to distinguish three types different from the one type of, bone. It's all from bone. So it's example how it looks for renal cells, how it looks for breast carcinoma primary, and how it looks for lung. If you can see, it's really all similar. It's really hard to distinguish. That's why we need help from IE. After applying FRAC-LAC and transforming in binary, we applied statistical analysis, and these are results, which is really good. By default, when you have three groups, by default it is 33, percent. On this way, accuracy is 78 and above, which is really good. For breast primary, it is 73, and for renal cells, it is 76 and above. So it was really, really good, because state of the art, there is no any other objective or computer analysis for diagnostics like this. You have only what pathologists said, and nowadays there are meetings, commission, and as I know, there is no in one voice, for five doctors that they are not agree. So I think like this will help and doctors and patients. Some recommendation for further researchers are exploration of applying possibilities multifractal analysis in diagnostics for other organs, for other cancer types, and improvements in this specific FRAC-LAC or other multifractal analysis in sense of speed, reliability, usage of easiness. And I am applying combination, as I said, with CNN, with convolution, and I find that is the best as I can see. So applying multifractal and CNN. Another project was, as I said, prediction of efficiency of applying chemotherapy response, which is state of the art. There is no such kind of objective or computer analysis. They just check maybe some health conditions of patients. On this way, you can have so-called individual health, conditions applying therapy. So this was a project after my PhD with the Institute of Oncology for breast cancer. That was all women. So we had three groups again, comparing results of multifractal analysis with tumor markers. That was another project. We were comparing fractal and tumor markers in order to find more reliable, faster, and cheaper solution of diagnostic of carcinoma. And my idea is to make some database of those microscopic images, because wherever I was in or conferences or innovation competition, and in China and Australia, it was surprised that they don't have approach to database. It was too much of those 150. They was surprised. I thought before it was little, but they said, how you find such big data? So my research was to open that, to be on internet. After that, I found why it's not in the internet, but I hope it will be, Okay, I will explain that. for prediction of breast cancer chemotherapy disease response. As I said, we had again 3 groups with first partial response, pathological, complete response, and progressive disease. And these were the best results. It is really, really good. You know, for 3 groups, we had accuracy over 91%, which is really, really great. Specific if you look that there is no objective, you know, like that, some analysis. When you, on this way, you can say to women, or, you know, I hope to every patient, you can say you know, individual you with that specific condition, you will have 91% of successfulness after applying this was some specific chemotherapy. It would be, you know, great results, and for that patient and for that doctor, I suppose it's not easy, and the doctor to just, you know, say, oh, you should apply this chemotherapy, and they are not sure. And nowadays, thank God, there are many other therapy, you know, immunotherapy, biotherapy. On this way, as I have heard, actually, Oncology Institute, every cancer is, you know, for itself. Every patient, every cancer is some combination. It needs some combination of chemotherapy. Even there, I heard, even for with cannabis, and there are many science actually papers, and with applying cannabis and high doses of vitamin C intravenous. So it's scientifically approved. It just needs some, you know, individual application, you know, to be sure that that patient will have best results of that combination applied. So these were results with prediction of efficiency of chemotherapy, and some recommendation for further researchers about that is a prediction for other kind of therapy. As I said, it was for some specific chemotherapy. It was really sad when I had a lot actually emails from patients with metastatic sending me pictures from biopsies. I was surprised that they have pictures, but it wasn't research for that kind of chemotherapy. So I would love to apply for other chemotherapy, for other else, whatever therapies, and comparing results of multifractal and CNN with tumor markers in order to find more reliable, faster, and cheaper solution in diagnostic carcinoma, and making database microscopic images. So my colleague from Institute and my best students, we made a so-called medical research platform, and we invited our academy and our private clinics in that. Like we wanted to make startup. We were in final of those competitions, but we haven't been. But I hope after, I don't know, some time we will get that project done. So the idea of that project were making like models of machine learning, applying on medical image basis, like computer tools in diagnostics, tumors, and other diseases. We are working now with the Parkinson, Alzheimer. You know, when they send patients to have a MR of suspicious to Alzheimer, and when they don't get that diagnostics, they are, you know, kind of said left it, you know, and in a common they get some psychiatrists some medicine which is not allowed in dementia, you know. Only autopsy is the 100% for sure diagnostic for Alzheimer. So I want to apply all of this in better diagnostics of Alzheimer, in order to avoid that lefting patients or getting the wrong medicine, which is really nowadays common case. So the idea was to gather on one place all doctors and experts in artificial intelligence and machine learning to find together better algorithms for early detecting tumors and for finding, as I said, primary tumors from metastatic, and for early detecting other diseases like Alzheimer, Parkinson, and on that way better treatments and on time. Applying machine learning and statistics algorithms in order to confirm this kind of accuracies. We need much more images and constant to check and verify with new data. And that's why I ask you for that lawyer. It's really interesting, maybe for that part of validation, maybe. I will think about it. This data collecting and application, this and other analysis is goal of this project. So to make one database on internet for, on this way, and the doctors can ask anonymously, and patients can get that second opinion, which is really important. And to be honest, and doctors need another, opinion to be sure, so applying data analysis, educational part of platform, even I on, in School of Computing, applying like this to show my students, but you can imagine what benefits could have medical universities just to show those kind of images. So sharing knowledge between doctors and students, making database, collecting all kind of data about patient health without respecting data privacy, collecting MRI images and other medical images, laboratory analysis, and following timely patients' conditions in order to improve methods when some new data come up. As I said, respecting all data privacy. Clinics put name, last name, and unique number in hash. So we have a unique number. We don't know any names or, any data of that patients, just some unique number, which is always questioned in that competitions for startups. And data analysis, statistical analysis. Doctors can use our biggest image database for testing their hypotheses and perform statistical analysis. Applying machine learning, and other experts in the area of machine learning can simply establish and test new models of machine learning, like we did for those predictions of efficiency of chemotherapy. On that way, they can have the largest medical database, not to have problems as I did to find the database. On this way, platform would have big number of methods for statistical analysis, and on that way we can find the best, some combination of statistical and machine learning algorithms. And as I said, the educational part of platform, and for University of Medicine, and for School of Computing, and on this way we can do some multi, areas research. Medical professors could find specific MRI or other images, medical, and make their comparing, and on that way improve their lectures on simple way, and also improve making decisions in therapy treatment and making therapy and treatment on time. Sharing data between doctors, asking questions, asking for second opinions, and in the same time respecting data privacy. Doctors do not want to be public information that they have asked for advice. So this part of site would be only for medical doctors. Asking questions is anonymous for who is asking, and patients and doctors. And cooperations with clinics, as I said, we have with the Institute for Neurology, President of Serbian Academy of Science, Professor Dr. Vladimir Kostić, medical group. It is the biggest private medical group, and on that way we have idea of collecting data from clinics automatically, and we want to, spread that on the whole world. So if you have maybe in your countries that kind of offer, that they can share, of you find some database opened images, we can collaborate on that way. And this is another image of fractals that I like. So if you have some questions, that will be all for me for now.